We are touching today BigIP, which is a good old BigIP platform from F5, but of course F5 is creating or trying to go with the time as applications are evolving. F5 does it as well. So let's talk about BigIP itself, about BigIP architecture. So for those that didn't see that product before, we have to understand that this product itself works most of the times as a full proxy. Okay, so this is a full proxy that will be before our applications from the client perspective. So if the client tries to connect to this to the application, we will be in front of this application and we'll actually try to establish connections from the client side and then do all the services that we need. So meaning the securing applications, authenticating this traffic from the client side, and so on, modifying that traffic, and then sending that traffic to the backend services. And this is something that we are going to configure today. From the architecture point of view, on BigIP itself, till today, okay, it's divided into management plane and data plane, which handles the client traffic. So something that is responsible for handling client traffic, the data plane, it's called TMOS. This is a separate operating system where all those modules we were talking about before, so LTM, right, DNS, web application firewall, authenticating the traffic, network firewall, DDoS protection, and everything else happens under this traffic management operating system. And this one, the right part of it, with a little bit less resources that we have on our boxes. This is the administration part, so management plane, which is responsible for administering our BigIP, administering our platform, modifying the configuration, gathering logs, and so on. And everything here is running on one platform, of course. This can be physical platform. As you can see here, many different models for existing devices. This is out of sale. Most of those platforms are already out of sale. Okay, so this is the iSeries and Viprium. So everything here is running this kind of solution for today. Okay, and most of those platforms are out of sale, but of course something new came in, which is called R-Series. So we have as well lower models like our 4,000 or 2,000 series or our 5 or 10,000 series here, which are architecture of those products is a little bit different. And of course, the most expensive and the best performing solution, which is called Velos. This is a chassis with some blades which we can put into it. And for now, everything still runs with this architecture. Okay, so we are building actually a TMOS or BIP administration. Doesn't matter if you put that on this older appliances, the new appliances, okay, doesn't matter how this new operating system works, or you put that into the virtual edition, which can be run in your own environment or in the cloud, actually everywhere. So the architecture itself is very, very similar under the hood. So we can run even all of those modules, as you can see here, we can run on virtual machine as well. So why BigIP is so it's pretty good. Why it's pretty good solution for everyone. Okay, and in my opinion, and in the opinion of most of the customers of F5, is the programmability. Okay, so this box or these solutions can be programmed according to your needs. So we have some scripts that we are going to talk about at the end of today's meeting. Okay, we can have some different control planes I call TMSH. We can have some templates automating our configuration within the box itself, but we can use something called automation toolchain. So meaning we can use external solutions, even open source solutions, to automate the configuration of our big IP. So the configuration can be created in seconds, actually, right? So everything is very flexible from this perspective. So yeah, it doesn't matter where you're trying to put that solutions. If it's your data center, if it's some co-location, if it's a private cloud, public cloud, doesn't really matter. F5 with big IP and all these API possibilities can fit every single part of the of your environment. Okay. So yeah, let's try it out. Let's try it out, and in just a few minutes, we are going to connect to our labs. This is something that you have to do when you get a new appliance. So when you try to install a new virtual machine, when you try to configure your big IP or physical big IP from scratch, you have to go through this process. This process is already configured. Okay, it's already done on our labs after you get access to it. So we don't need to license the box. We don't need to enable those modules and so on and so on. And even the network is already configured. So those VLANs and everything else, it will be already configured after you connect to our lab environment. That's the user interface. So if someone has not tried it before our meeting here, after you log in from the browser to our big IP, on the left-hand side, there are some tabs that are related to specific configuration of our product. Actually, today we will focus on that one. So local traffic, we are going to configure local traffic manager, right? So we are going to configure all the objects within that tab. But of course, after you provision some other modules, other tabs can appear here. Additional security solutions, additional options, like, for example, SSL orchestration, etc. So that's the GUI interface. Of course, everything right now can be configured as you configure your big IP box from the GUI. Everything can be configured from the command line as well. Today, we are going to focus on the GUI configuration, but in this link that I've sent you before, there are materials to today's labs. There are also some parts of the configuration that you can try to use to configure those objects from the command line itself. Okay, so after you, let me try to skip here. Okay, so you can configure some objects from GUI or from the TMOS shell. TMSH, it means traffic management shell, or TMOS shell, right? This allows you to configure exactly the same objects from the command line. So this could be useful to, let's say, automate the configuration. But of course, for this real automation, F5 has other options like API or REST API access to the big IP, which we are not going to talk about today. We are not going into the details about automation of our big IP. Here we are going to talk about the basics. Okay. So what is absolutely necessary to be created on big IP? What kind of objects we need to create to publish single application? So we have a purpose to publish single application, which we have in our data center on some specific server, right? we have this big IP, we bought it, or installed a trial virtual machine, and we want to publish our application into the internet. So what kind of configuration on LTM itself we have to do to be able to publish this application? So first, we need to understand some object types, and then we will configure it. So from the lower level perspective, we will talk about something called nodes. Okay, nodes are nothing else than just an IP address of your backend server. Okay, so in your data center, you have a server, physical or virtual machine, whatever, and you want to access the application existing on this server. So this is the node. This is necessary to be configured on BigIP because of routing perspective, etc. Then you have something called pool members. So on this node, on this physical or virtual server, you will have some services running. I mean, your applications, right? So you will have some IPs and ports that are available for the clients. So we can have plenty of applications on one physical server, right? That's why we talk about single application, meaning pool member. And the group of those pool members, so the group that is representing your application, the group to which BigIP will load balance the traffic. So we will try to send the traffic across those pool members, is a pool. And this pool, in the simplest configuration, is usually assigned to specific listener here, which is called virtual server. And you can do some different configuration on the pool level and on this virtual server level. So for example, on pool level, we are going to configure some different load balancing methods like round robin or ratio here. We are going to talk about that later on. But with the simplest configuration, round robin method is a default configuration here. And we create something called virtual server, which is listening for the client traffic. And by default, it can be assigned one default pool. So this is the simplest configuration and can send traffic to this specific application or copies of those applications existing on different nodes or pool members. BigIP by default is not passing any traffic. So it's not like a open switch or whatever. It will not pass any single packet before you configure those objects. So you have to configure at least few of those to be able to pass the traffic through BigIP. Otherwise, it will not pass the traffic through this unit. And of course, you can have plenty of applications configured there in the backend, in the front end, I mean, from the client perspective, which are those virtual servers. It really depends on the architecture you want to achieve. This is the simplest configuration. We are going to talk a little bit about the configuration with different types of those listeners, but this will be handled later on. So the most basic configuration to publish a single application to our clients is to create all those objects I mentioned. We don't need to create nodes manually. We can start with configuring a pool and pool members, so services within that pool. So we go to pool, then we try to create that pool. So clicking plus or here, create the pool. And what we need to put here is the name of that pool, which cannot be modified later on. Names are something that is not that we are not able to change after we create that object. At least it's not so simple. And you add those pool members. Okay, so new members, you put an IP address of that backend service and service port. And this node object here will be created automatically after you click add and finished. And you can add one object as a pool member. So you have one virtual server in the front end and one backend pretty often. But you can have, I don't know, hundreds or thousands of those objects behind BigIP. And everything then will be load balanced with this selected load balancing method. We will talk about that load balancing method later on. Some configuration we are going to mention later on as well, like health checks, health monitors, priority group activation. Let's leave it for now. We are going to configure as simple configuration, as simple objects as are possible. Okay, so we'll have this kind of configuration here. Let me try to, clear that. So we have a pool built from 3 different pool members. So that's something that represents our backend, and then we need to configure our front end. But before that, take a look. Those nodes were created automatically, and this is exactly what will happen in your environment. Okay, so you will configure pool and pool members, and nodes for unique IP addresses here will be configured automatically. And then we skip into the configuration of our virtual servers. Let me try to go to the virtual server configuration. So plus or create new, and then you put a name of that object, and you put the values for destination address and service port. So on which IP address you want to listen for the client traffic. Sometimes this can be some public IP address. If you are behind some firewall in front of your BigIP, maybe there is some kind of address translation that can be private IP. It really depends on the architecture you have. So the simplest configuration, the name, destination IP, service port. Then you can scroll down, okay? You can scroll down to the configuration of your other settings within this virtual server. Of course, depending on the needs, you will need to modify those profiles. We are going to talk about profiles later on. So plenty of different profiles that can be assigned to your BigIP. We are going to make to talk about that later on. Some translation. This is something that we are going to cover as well. But the simplest configuration you're going to do in the lab is to scroll down to the bottom and go to the resources tab, okay? And on the resources tab, there will be a default pool to assign to this virtual server. So you have this default pool, you assign this default pool that you've created a minute ago, and it goes, okay? And it should be running in our environment without any issues, without any problems. In real life, in real environment, this configuration sometimes has to be customized. And to fit into the requirements, we will need to configure those profiles, modify the traffic, do something with the traffic on BigIP. But that's the basic configuration. Nothing else has to be added to be able to pass the traffic through the BigIP itself, okay? So those are the mandatory settings here. How BigIP processes the traffic by default, let's say, okay? So with configuration of those objects that we mentioned. So simple pool and simple virtual server. So we have this kind of listener, let's say, and we have a client trying to connect to our application. So the client, of course, puts the name into the address bar of the browser. Some DNS resolution happens, of course, and somehow magically the user comes into our virtual server. Okay, so this is the IP and port listener on our BigIP from this client-side perspective, from the internet point of view. What BigIP does for this? If we have this kind of pool in the backend assigned to that virtual server, so BigIP sees this IP addresses from client side. We are a proxy, remember. So from the client side, from our proxy perspective, we will see the source IP of the client and the port, source port, and destination IP will be this IP representing our virtual server. In the backend here, we have to make a load balancing decision where this traffic should be sent to this first, second, or last pool member in our pool. So depending on the load balancing decision, let's say this should be sent to the first pool member, and how it looks. Okay, so actually this destination IP here, this is the request packet, remember. Okay, so this is the packet that is being sent from big IP to the backend server, selected by load balancing algorithm. Destination IP will be the IP of the selected pool member, and of course the port of this pool member, but the source IP will be the original client source IP. So by default, F5 does not translate the source IP of the client traffic. So sometimes this causes some issues, maybe not issues, but additional configuration has to be made to bypass that issue. Okay. Second traffic, second connection, we can send that traffic to different pool member. So what we are doing, we are load balancing the traffic. We need to do our best to send this traffic equally across those pool members. Okay, so asymmetric routing problem. So sometimes when, or very often, your backend servers will be configured with different default gateway than F5. Okay, so they will try to send all the traffic to some kind of router or firewall, not our F5 big IP. So if the traffic comes in to our service and is sent to the backend server here with the original client IP, sorry, this is the source, client IP, this server will try to send the traffic not through the big IP, but with according to the routing configuration on within the routing table. So we have asymmetric routing problem, and unfortunately, somewhere in between the client and the backend server, something will block this traffic. So what we need to configure, what we need to do in most situations that we have to configure something called secure network address translation, but most of the times we call it source, of course, network address translation, because we are translating the source IP of the packet coming in from the big IP to our backend server. So it means that this backend server knows that this response has to be sent through big IP. This is the response back to the client, and it has to be sent back through big IP. And this is the most common configuration in most of the environments. Unfortunately, what we miss in this configuration is the client IP on the server side, right? Because in this packet, request packet, what we now see as the source IP, it's not original IP address from the client, but this is the IP address of big IP, of the big IP itself, some kind of IP address on the interface, on the VLAN configured, or maybe some selected configuration that we've created customly with custom configuration on big IP. Okay, perfect. So that's the basic configuration on our big IP. And if we want to configure this source address translation, the easiest configuration that we can do is configure this SNAT or source or secure network address translation and use this automap configuration. So automap means that big IP will automatically assign to the source IP address specific IP of its correct IP address from VLANs according to the egress VLAN, depending on which VLANs you have your backend backend services. So it will actually automatically assign correct IP address. You don't need to worry about that in your configuration most of the times, of course. And the configuration is here: source address translation, and then enable automap. So we are going to configure that in just a second. So this IP address here, when you select this source address translation, will be one of your IP addresses configured on your VLANs. So this configuration is already prepared in our lab. So you will have those two different IP addresses for external VLAN, so the client side, and internal VLAN, server side, backend side, right? So the source IP will be translated by default to this IP. Of course, when we are trying to configure some clusters, high availability configuration, you will have some virtual IP addresses. So if someone of you is aware of how, for example, VRRP works, so this is pretty similar to VRRP configuration of the high availability here under Big IP. Of course, we are using specific protocols by Big IP, but it's very similar to this kind of high availability configuration. Here we are using just a standalone architecture, so we will need only those single IP addresses. Okay, and actually at the end of this lab, what we are going to do is go to network map, review some configuration of your services. Of course, at the beginning, you will have just one virtual server with specific pool assigned to that. Don't worry about those statuses, those colors here. We are going to cover that later on. And after that, you will go to some statistics. So you go to module statistics, LTM, local traffic statistics. So you will see statistics from the client side on the virtual server level, and on the server side when you go to the pool level of your statistics. So that's the goal of the first lab that we are going to do here. Going further with this configuration, let me try to, okay. Most of the times you will configure this kind of virtual server with single IP address, single port, and single pool representing one application. But sometimes maybe you want to pass the traffic differently through your Big IP. Maybe you don't want to be a reverse proxy for single application or many single applications, right? Connecting to one IP address. Maybe you want to configure your Big IP not to be a reverse proxy. Maybe you want to be, I don't know, forward proxy, or maybe you want to pass the traffic through Big IP, just like you will pass the traffic through the router or any kind of firewall that you have. So for this purpose, you will have different types of your virtual servers. That's the first option. And probably you will need to sometimes configure some network listeners. So I mentioned that this configuration is something representing your app, right? But actually, this should be treated as a rule that allows to pass the traffic through your Big IP in specific ways. Okay, so in our lab, in just a second, you will configure, for example, forwarding IP virtual server that handles the traffic as a firewall. So the traffic has to be sent to your IP of your, in this case, IP of external VLAN, and send the traffic, pass the traffic to any of those IP addresses in our backend subnet. So this is something we are going to configure like here, okay? So the client will try to connect directly to this IP address, not to the listener, like the app from the client side, but the destination IP address will be this, okay? And this is how it will be sent using forwarding IP virtual server. That's the goal of the other part of this first lab. Okay, what you can do from the security perspective, of course, when you try to run those listeners, like very specific or list specific like subnet or even wildcard virtual server that allows you to pass everything everywhere. Okay, so you can enable or disable those listeners on specific VLANs, for example, or enable, disable ARP responses on those VLANs. You can review how it looks. So after you configure this forwarding IP virtual server in your lab, please review virtual address list. Those are objects that are also automatically configured, just like those nodes. Here, virtual addresses are configured automatically. Please go to this IP address of this the 10.1.20.0 that we will create, and it will have ARP here and ICMP echo disabled because I don't want to respond for ARP for every IP in specific subnet, right? So that's the goal of the configuration. And if we have plenty of different virtual servers on BigIP, that's the order of how they are being processed. So they are being processed from the most specific to the least specific. So if, for example, you have some virtual servers like this one, 172.16.0.0, and you can have virtual server like this one, 172.16.1.2, for example, right? So this one will be processed as the first one, okay? And everything else not hitting this one will be processed by this, from the most specific to the least specific. That's the goal of our first configuration for this first lab. Introduction to load balancing. F5 is a load balancer, okay? So everybody knows F5 working as a load balancer. If you see this large F5 on the box in the data center, you can put a finger in it and say, this is a load balancer, right? Because everybody knows F5 as a load balancer, but it can do a lot of different things. But let's talk about this load balancing, at least here. So load balancer means that we are trying to put a load actually for our traffic on different servers for one application. So we have 5 or more servers representing our application, right, in the backend. And we are actually trying to put some load on each of those services, on each of those servers. There can be one server, there can be hundreds of those servers. We sometimes want to to put the traffic equally across all of those backend servers. Sometimes not necessarily equally, because we can have some new servers, some old servers. So the brand new great server can handle maybe 10 times more connections than some other old servers that we have. Or maybe on the other servers, we have other services running, and there's a performance impact because of those services running on those servers. So load balancing means putting a number of traffic or connections or some traffic according to our needs. And there's plenty of load balancing algorithms that we can use on our BigIP. Some of them are called static load balancing methods. Some of them are called dynamic load balancing methods, okay? So when we talk about static load balancing methods, they are not taking into account actually anything, okay? They are static. So round robin and, for example, ratio, those are static load balancing algorithms. When we talk about dynamic load balancing algorithms, they're taking into account when they are making the decision where to send the traffic, some metrics, some more factors according to what's happening with this traffic, okay? So some examples, okay? So those static load balancing algorithms, round robin, the default one, and ratio, this is a weighted round robin. I would call it like this, okay? So it's a little bit like a round robin, but we want to put a little bit more traffic to particular servers. configuring their weights, right? I will show you how it can be configured in just a second. And dynamic load balancing methods like list connections. This takes into account active open TCP connections to the backend server. So if I have a server that has the lowest number of active TCP connections opened from the big IP perspective for particular service, this backend server will be selected by this load balancing algorithm. So this one chooses the backend server that has the lowest number of active connections open from big IP perspective, of course. Fastest means that I'm trying to select the fastest working backend server. What does it mean? Fastest working backend server means that I need to verify how many requests, and in this situation, we need to have layer 7 awareness on big IP. I will mention about that during profiles chapter. So I will send some requests to my backend server, right? And the backend server that responds as the fastest, right? As the fastest backend server, this one is being selected for next connections. I don't want to spend time talking about that one too much. Observed and predictive, those are load balancing algorithms that are configuring some dynamic ratios, which we don't see in the configuration, which we don't see actually on the system at all. And this allows us to modify dynamically the ratios between our backend servers. So it means that for, I don't know, few seconds, I was sending a little bit more traffic to the first pool member. For the next few seconds, I will send a little bit more traffic to the second one. And it changes dynamically over the time and the history on how we were load balancing the traffic. And we are trying to put the load equally across those backend servers. So observed and predictive, though actually they are working very similarly. Okay. Dynamic ratio, that's something that can be configured as well as a dynamic load balancing algorithms. This one is a little bit different than the others because this load balancing algorithm requires from you to assign something called health check or monitor and to verify what's the load of the CPU and memory on the server. So it requires actually from us to install some agent on the backend server, but it allows us to send the traffic to the lowest loaded server, right? Because we know that specific server has, I don't know, CPU over 60% or 70%. I don't want to send the traffic to that one. I will prefer the one that has lower than 30, for example. So this is how we can use dynamic ratio. And those are load balancing algorithms. When you go to the big IP, so you try to configure, sorry, not that connection. It will be this one, yes. When you go to your pool and you try to create a pool with specific load balancing algorithm, there are a little bit more load balancing algorithms, but if you will read all of them, most of those load balancing algorithms actually appear twice on this list. So it really depends how we calculate statistics, because we can calculate statistics, for example, for these list connections, we can calculate statistics based on pool member or single service on that backend server, or based on node. So calculating statistics for the whole node, all the services that are configured on big IP. So for example, if there are 10 services on big IP, on that node, we will calculate all the connections that are opened for all of those services that we are using from big IP perspective and sending the traffic to. And there are some failure mechanisms. What big IP will do if we are not able to send traffic to those services? So they are not working, they are disabled, or maybe they are unavailable based on health checks, which we are going to cover later. So if they are not available, we can use some kind of priority group activation feature, maybe fallback host. We can use iRules, so scripts for that. We can use other features on big IP, which actually handles the situation where something is not accessible. So priority group activation, which is actually used very, very often. Here, there will be, just a second, I've seen that already. There is some kind of a little bit, maybe not difficult, but the configuration is quite complex here. For this priority group activation, this feature can be used, for example, to send the traffic as active standby. So your backend is working as active standby server. So you want to pass the traffic, all the traffic, to the first backend server. And if it's not available, then you switch to the other. Here, we have some more complex configuration done. So we want to have the traffic being sent to, let's try to go here, to those servers, okay, with some kind of priority group. So we are prioritizing higher values, and this is treated as the same group, okay? So by default, we are sending the traffic only to this group of backend servers, unless the number of available servers in this group will be lower than 5 active members. So if they are all active and we disable one of them, or maybe they are being unavailable, they are unavailable because of health checks, we start to send the traffic to other group. So it looks more or less like this. Okay, so by default, everything is okay, everything is fine. I'm trying to send the traffic only to those servers. And if one of them or more of them is dead, okay, is unavailable or disabled or whatever, then it's less than 5 available members. I'm trying to activate, that's why it's called activation, priority group activation. Okay, so I activate all the members from lower group. And right now, I'm load balancing the traffic across all of those pool members. And again, if they will start dying and I will have less than 5, then I will activate again those values here. Okay, so activated priority group with number 15. That's the configuration. Very often, you will not configure this kind of complex configuration. Very often, you will have something different here. So I will show you just a second how it can be configured. Of course, you can configure that in your lab. You will configure a few backend servers with different priority group values. This is configured here. And you will try to see where actually you're going to send the traffic. Because priority group activation decides where we send the traffic, and load balancing algorithm says how to send the traffic. So equally or not equally if you select ratio or whatever. So to make it work, I have to set those values here for priority groups and then enable that feature here. Priority group activation, I will activate next pool members when the value of active pool members will be lower than this configured here. So let's say we will put 5 active members here. Then we will configure this priorities like that. So 40, 30, 15. And then after they will start dying, okay, I will be activating more and more members. Okay, so let's continue. Hopefully, if someone has something to do according to the previous labs, you can have some time in the meantime, or maybe in the afternoon, or you can review that configuration tomorrow, even in the morning, right? Before we will start our meeting at 12:30, you can always play around those labs tomorrow in the morning, if you will have access, of course, because no one has confirmed that to me. So monitors or health checks, you can use different naming here. So if we are talking about application monitoring, we are talking about analyzing its health if it's working. Because if you are load balancing the traffic across different servers, across different pool members, actually, then we want to load balance the traffic to the ones that are working fine, that we know that the application is working correctly, not to the ones that are disabled or broken. So we need to test the application, and most of the times we use some active health checks to test the application itself based on different types of health checks. And here we are going to talk about those different types of health checks. So BigIP actively will send specific request or traffic or connection or whatever every few seconds, for example. So that will be the interval that we are configuring. And after some time, if we don't get proper response or we don't get any response, we will mark those services unavailable. So we are not going to send the traffic to those services anymore, to those pool members anymore. Okay. So yeah, that's pretty important. Monitors are served from the self IP addresses. That's pretty important when we talk about high availability. So you have self IP addresses, right, for specific boxes in the cluster, and you have the virtual one as well. So if you have this virtual IP address, you will never try to monitor your backend services using this virtual IP address. You always use self IP address. So in our case, the IP address we are trying to test the application in this situation will be, let's try to find this, will be the IP address of my internal VLAN. Okay, so I'm trying to send those checks from this IP address. Okay, so let's continue. What types of checks I can do from my BigIP? So I can use different levels actually of health checks, node checks, service checks, content checks, and so on and so on. So node check, this will be the simplest check that it's actually, I call it simplest check that is available because we are using ICMP request and we are waiting for the reply from the server. So this is called node check because we are actually testing only IP address. That's the goal of ICMP. We are not testing any port here. Service check means I'm trying to open TCP connection or half open TCP connection to my backend server. So I will send a SYN packet. I'm just waiting for SYN ACK from my backend server. That means that any kind of service is alive on that port. So it means that this service is active, but does it mean that my application is running fine? Does it mean that my web server or application server or database server is running correctly? Not really. So it's actually recommended to use content checks. So it means that wherever possible, use some health checks, use some monitors at, let's say, layer 7, if I have this kind of application, to verify the health of the application with some a little bit more comprehensive way. Okay, so I'm sending some kind of requests, and I'm suspecting that the application will respond with some characters, with some specific string that will appear in the response. This is the content check. So in my opinion, this is something that should be always configured for example, web applications. Overview, of course. Till now, we were not using any health checks, any health monitors at all. So we don't know the status of our backend application. The status is this, okay? So blue square, which means that I don't know what's the state, if it's working, if it's not working. But if I don't know the state, BigIP will always try to send traffic to this object. It doesn't matter if it's dead or alive. BigIP will try to load balance the traffic to that server and never get any response because it's not available, for example, right? So this is the status of unknown. I don't have any health checks, any monitors applied to that service. Again, if I applied any kind of health check, and it doesn't matter if it's on layer 3 ICMP, right? For TCP or TCP half open, or maybe on layer 7 HTTP monitor, and I get a response, correct response, I will see a green circle, which means that my health check is running fine. Still, does it mean that my application is running fine? Maybe I'm using ICMP health check. So I ping my backend server, but web server is down, or my Apache or Nginx or database is dead, whatever. The green means that everything works fine depending on the correctness of configuration of your health check. If you have very, very complicated health check, which analyzes your application in details, then you can be sure that everything is correct, everything is fine. But unfortunately, if you use some health checks from low levels, low layers like ICMP or TCP, unfortunately, that's not clear information for you as an administrator that everything is fine. And of course, if you applied specific health check to your application, to your services, and we don't get suspected or response that we need to get to make it available, we mark that service offline. So it means that we are not sending packets anymore to that services, okay? So it's offline after some time. Yep. If it's online, so if it's going back online, and BigIP see if it's alive again, it can start to send the traffic to this object automatically, or can wait for you as an administrator to enable that object. So it will be disabled for some time if unless administrator will re-enable that. So you have few administrative settings or statuses that can be set to those objects. I will show you that later on. So where do we configure monitors? Health checks are being configured here, right? ICMP, you always should customize your health checks. So you can't customize the defaults. You will create your own health checks, then configure the name, select the type of the health check, and how often the test will be done, after how many seconds you will consider that service that is dead, not running. This is, of course, the layer 7 HTTP monitor. So you will have to configure the request. And this is the receive string that should be in the response. So if you get this receive string in the response, then you mark your pool member online. If you don't get any response or you don't get this specific string here, you mark it down so you don't send the traffic to that pool member. Okay. I'm skipping all of those other settings because we don't have much time for this. Usually we leave that as it is. So 5 seconds, the interval, and after 16 seconds of no responses from the backend servers, then we get then we mark it offline. Okay. We can modify that, of course. The same is for nodes, so you can assign your pool members to pool monitors to pools. You can assign it directly to pool members. You can assign it as a default for nodes and for nodes for specific node as well. So we have many different choices of monitoring your backend servers. If we are talking about the pool, usually we are assigning one health check to your pool. And this is something that we are going to configure in the next few minutes. Assign that and wait for the response. Let's continue with this, with the next chapter, which is profiles, using profiles. As I mentioned, if you wasn't able to finish those labs are available for you probably in the afternoon and tomorrow. So profiles. What are profiles? Actually, profiles can have different meaning on Big IP. Profiles actually, just like here, profiles affect your virtual server on how it behaves according to the traffic that is passing through your Big IP. So profile can be actually anything, okay? Profile can be how you decrypt the traffic, that you modify the traffic, that you do some optimization of the traffic like compression or cache or whatever. Profile can be allowing you to parse or understand the traffic at layer 4 as TCP or UDP, at layer 7 as DNS, HTTP, whatever it is. So it allows you to understand the traffic or be able to do something with the traffic for specific protocols. According to the profiles, some of those profiles will be applied directly to the virtual server as they are configured by default. So very often, if you don't want to modify your profiles at layer 4, for example, TCP, then you can use them as they are configured by default. But very often, on the other hand, some other profiles will be customized. So for example, when you want to use HTTP profile and you want to insert some headers or delete some headers or do something about that, you will need to customize those profiles. Or if you want to decrypt the traffic with specific key and certificate, then you have to customize your SSL profiles. So this is what you do with profiles. And those profiles can be on different levels, as you can see here. Layer 7, layer 4, maybe persistence we are going to talk about in next chapter. SSL, maybe authentication, some security settings that you want to apply to your virtual server. I mean, for example, web application firewall from DDoS perspective, from bot defense perspective. This is something that will be some kind of profile, okay? So many different profiles to configure, many different profiles to use, as you can see here. So if you want to parse the traffic on different levels or on different layers, according to OSI model, so we have from 1 to 7, right? If you, for example, want to do something with some kind of headers, if you want to modify the traffic on layer 7, it means that you will need to apply to your virtual server HTTP profile. So otherwise, if you don't have this HTTP profile, you don't understand this layer 7. It means you can't do anything about that. HTTP works with TCP, at least till HTTP version 2. So because it uses TCP, you have to apply to your virtual server both of them. So at layer 4, you need to have TCP profile applied to your virtual server, and at layer 7, you have to HTTP profile applied to your virtual server to do something with cookies, for example, or whatever you want to do. Maybe you want to load balance the traffic based on layer 7 decision. That's exactly the same situation. On the other hand, if you applied to particular virtual server profile on specific layer, like this layer 4, and you want to parse the traffic as TCP, at the same time, you cannot run the same virtual server, I mean IP and port, to run UDP application. This will be able to run on different port or different IP address. Okay? The same is on layer 7. So exactly the same situation. When we talk about profiles, profiles are being applied most of the times to the virtual servers. So as you can see, some protocols or layer 4, HTTP profile, FTP profile, encryption, so SSL profile, etc., etc. There are plenty of different profiles that can be applied to your virtual servers, modifying the behavior of that virtual server in the context of the traffic that is passing through this. How do we create those profiles? We should never modify default profiles. It's possible to modify default profiles, but we should never modify them. This causes issues in the future. So you should always use them as they are, or create your custom profiles based on those default settings. So you have some kind of parent profile, and if you want to modify that one that you configure, for example, you want to, I don't know, maybe erase some headers, insert some headers, you check this box. Okay, you customize that setting, particular settings, and you modify something in this profile. So for example, I don't know, fallback host, fallback on error code, and then you apply that profile to your virtual server. For example, sometimes this is the situation where you can't do something with default settings on your virtual server. For example, I know compression, web acceleration, HTTP something. It means very often that you don't have applied at the top here. Let me scroll back. HTTP profile. So you don't parse layer 7. The same situation will be if you want to do some layer 7 load balancing or anything like this. If you want to apply web application firewall policy, if you don't understand layer 7, you can't do web application firewalling. You have to use this kind of profiles, allowing your big IP to understand layer 7 HTTP traffic. And then scroll down, and then you can apply additional profiles related to some optimization, like caching, compression, or whatever it is. Okay. So yeah, actually from the big IP perspective, how it handles the traffic, it modifies actually handling this traffic a little bit when you have applied something from layer 7. So for example, according to the first screen that you've seen, or one of the first screens related to the architecture or the proxy architecture, you will need to have this full 3UN handshake, TCP handshake, and then maybe the encryption and so on and so on, so TLS or SSL, and then you get this GET, right? So any transaction on layer 7, big IP makes a load balancing decision after all of this happening on the client side. So after that, it will open the connection to the selected backend server. So this is how full reverse proxy will work after you assign some layer 7 profiles to your virtual servers. All of those profiles are being actually being set in different tabs here. So services, content, persistence, depending on what they're doing. services, HTTP, one of the most common profiles that you want to assign. For example, the most common setting that you are trying to do with this profile is inserting X-forwarded for. So if you do some source address translation, you remember this automap feature on the virtual server level. In that case, if you lose the IP address, the original IP address of the client in the backend on the backend server, you should inform that backend server what's the real client IP. So very often you want to insert that X-forwarded for. So that's something that is very easy to configure. You create your custom profile, you enable that feature, and in that case, you insert that X-forwarded for header in the traffic going to your backend server. So in that case, configuration is pretty straightforward. So we create that profile here. You can try this in your lab, depending on what you are going to do. You create that profile. I was talking about not modifying custom HTTP profile. Okay. And I want to insert this X-forwarded for header. Okay. So I modify that setting. I enable that here. Finished. And what I need to do, I need to apply that to my virtual server. Take a look. This application is configured to show me request headers that are coming into the backend server. I don't have X-forwarded for, right? So after I will apply this newly created profile to my virtual server. So let's try to do this. So I select that custom HTTP profile, update. Okay, and take a look. The traffic comes from BigIP IP address. That's the self IP address on my BigIP. I don't see the client IP, original client IP. Inserting this, just one checkbox, right? And you can do plenty of different things according to your profiles, like this HTTP. It really depends on the usage of your application. So let's go through these persistence profiles because time is running fast. So let's go through this. Seal profiles. We are talking about persistence. What is persistence? When you try to load balance the traffic across many backend servers that you have. In this example, we have 4 different backend servers to which we are load balancing the traffic from different clients. And if your application that you are serving to your client is some kind of stateful application, so somehow handles the client session, maybe the user is logging into this application, and between backend servers here, we don't have any synchronization for that session. In that case, after first load balancing decision being made for first connection here to this first pool member, all subsequent connections should be sent for this particular client to the same pool member, to the same node actually, right? So this is what persistence means. Some kind of sticky connections, sticky sessions in other meaning. So we are trying to put all the traffic from the same client to the same pool member, be able to keep the session for that client from the same pool member. Other clients, of course, can be load balanced to different pool member. And in that case, the session for that particular client will be handled by this backend server. So this is the goal of persistence. And we have 2 options to choose between. So cookie persistence, destination or source IP persistence. This can be based on RDP persistence from Microsoft, SIP SSL persistence, or some kind of universal persistence that can use actually basically anything. Because here we create a script telling our BigIP, take this or that from client traffic to persist the session. the most commonly used persistence profiles are those two. So source IP persistence and, not or, and cookie persistence if we talk about HTTP applications. So most often we are using BigIP to pass this HTTP traffic, of course. So those two different methods are being used together. Why together? Because we are using, in that case, two different profiles at the same time. So when you go to your virtual server configuration, HTTP virtual, you will see here primary persistence profile or default persistence profile and fallback persistence profile. And the configuration that you're trying to achieve here is very often configuring cookie persistence as a default persistence profile for HTTP applications and source IP persistence as a fallback persistence profile. I will talk about those two profiles in just a second and explain why we are using both at the same time very often. So source IP persistence profile is actually using the source IP of the client connecting to my virtual server. And I will try to store that information for that source IP of the client in my persistence table. So this is very important. We are using persistence table, which is separate from connection table on BigIP, persistence table. And I'm storing that IP address. And together with this, I'm storing the information about chosen pool member. So in this persistence table entry, I will have information who and where should be sent. So for every single connection, new common connection that is coming into our BigIP, we are checking this persistence table to verify if I have any IP addresses which should be sent to specific pool member. Okay, so of course there are some drawbacks according to this. So this can lead to very large persistence tables when we, for example, create this every single entry for every single IP address, but we can do something with prefixes. So we can configure in the profile the prefix of /24 or /16 or whatever. So we will have lower number of persistence table entries for subnets, not for particular 32-bit IP addresses. But still, we handle that in this persistence table. And the other type of profile for persistence that is being used the most often is this one, cookie insert mode. I'm not going to go through those today because we don't have time for that, but cookie insert mode means that I have to play with HTTP application because cookies are in HTTP traffic, right? And what BigIP does here, BigIP inserts its own cookie automatically after you assign that profile to your BigIP. It will insert the cookie, and inside this cookie, there's an information about which pool member should be chosen. Okay, so we don't store the information in the persistence table like for source IP persistence here, but the information itself, which pool member should be chosen, is inside the cookie. So the client, every subsequent request or connection is coming with this cookie, and we know that we should send that to pool member 1, 2, or whatever. So those are the most commonly used persistence profiles. So the configuration of source IP persistence, just like other profiles. So we need to select the type, we need to select the parent profile, and two options, two things that we need to be aware of. And the most often configuration here happens here. So the timeout, how long I will store the information in my persistence table entry. So after 180 seconds, it will disappear from this persistence table. So I will be able to load balance the traffic somewhere else. So I should have very similar value here as my application actually keeps the session for a specific user. And prefix, By default, it's 32-bit, but I can put /24, as I mentioned, right? /16, whatever. Okay, so that's the configuration of persistence table. And I will assign that when creating virtual server here, or when editing virtual server under resource tab, where our pool is being configured. This is something that I configured already, right? So let me try to show you how we can configure cookie persistence. I'm not going through those for this right now. I would just show you this in the configuration. So when I go to profiles and I will create a cookie persistence, some custom cookie persistence profile, okay? My cookie persistence. The persistence type, I will select the method of cookie insert. I'm not going to talk about other options. This is the most commonly used. Okay, I will put a name, or I will not touch anything else here. Okay, so I will configure that profile, and then I will show you what should be modified in that profile from security standpoint. So take a look. When I go to my virtual server resources, I will try to use this my cookie persistence. What I'm going to do from big IP cookie decoder, you can try to look for this and add that to your Chrome browser. I just want to show you something because this is pretty important from security perspective. Let me try to add that to my browser. Yep, should be added, hopefully. Yep. So I have it on my virtual server level. Let's try to go to my virtual server. Let's try to go here. And let's try to review developer tools. Network, Control F5. So persistence means that after I was connected to node 1 or pool member number 1, all subsequent connections or requests in that case as well should be sent to exactly the same pool member. So as you can see, I'm not load balancing the traffic across those pool members because all the traffic goes to number 1, not 2 or 3 or whatever. And what I have here, there should be a cookie, okay? In my first request, of course, there should be set cookie here, but I enabled those developers tools a little bit later. That's the cookie. And it's called big IP server, HTTP pool, that's so the name of the pool, and so on and so on. That's not so good according to the security standpoint, but I can quickly modify those values. So when I go to persistence profiles, and I go to my cookie persistence, I can put the name of that cookie, whatever, and what I can do, I can encrypt that value, okay? Because normally, where is this? Here, take a look. And when I try to show you with this cookie decoder, this value can be easily decoded. So I know what's the backend IP address scheme. This is the IP address of my backend server, right? I should at least encrypt that and modify the name of the cookie itself. So let's go back to the configuration. I will do the configuration for whatever cookie and put that passphrase. Maybe I want to have this cookie that expires after, I don't know, 5 minutes, for example, or session cookie when I disable that. So update that. And now when I refresh my browser, okay, first, there's whatever cookie with some strange value. This is encrypted and it expires after some time. So right now I can't view what's the value of the cookie. Yeah, whatever, right? Blah, blah, blah. And that's it. So this is the configuration that you can do very, very quickly. And of course, in addition to that, that would be the primary profile. And the fallback persistence profile would be the source IP persistence. And in the lab, you will try to review persistence table entry. So when I refresh my browser right now, once again, refresh it, okay, and review persistence table entries, show LTM persistence. This can be viewed from the GUI as well. I will see that this IP address, so my client, my Windows, will be sent to this full member. It's 12, right? 12. Let's start the last part for today's meeting, which is handling encrypted traffic, configuring SSL bridging and SSL offload. What is that exactly? So I think that you all have some knowledge about how SSL works and what are the concepts of SSL. We are trying to encrypt the traffic to make it more secure, of course, right? So we will decrypt the traffic on the backend server and encrypt that in both ways, actually. When we have big IP in between, so we have big IP between the client here and backend servers, we have few different options. So we can pass the traffic as it is based on layer 4 decisions. So we don't need to decrypt that at all. But if we don't decrypt the traffic on big IP itself, we can't do anything from layer 7, right? Because we don't understand, we don't see layer 7, the traffic is encrypted. So that's the first element. The second thing is actually, we can't do anything with this. The second is that big IP can do a little bit more about that traffic. So big IP can optimize that traffic. It can take actually the necessity to encrypt, decrypt the traffic on backend servers. So we can give that actually that work to big IP, which has some optimization in hardware according to SSL decryption and re-encryption here on the chassis or on the big IP physical boxes. So this drastically, as they say here, drastically improves the performance of our backend servers. It really depends. Sometimes you're being enforced to re-encrypt the traffic on the backend side, but it really depends on the configuration or the architecture that you want to achieve. When we talk about SSL bridging, we are actually decrypting the traffic for the purposes on big IP itself. So the traffic inside of the big IP is unencrypted. For example, we want to scan that with web application firewall. We want to do something with this traffic. We want to see those headers, cookies, whatever it is. And then we want to re-encrypt the traffic to the backend servers. This is called SSL bridging. But very often we use our big IP to offload that from servers. So it means that only client side is encrypted and server side is not encrypted. So we don't need to encrypt that on the server side. Maybe instead of doing that from the presentation, I will close that one, okay? And I will try to configure something on BIP. So I will show you what is the most common configuration when we want to do something with encryption or SSL on our BIP. So first, we will need to import our certificates because we will not use probably locally signed certificates by this BIP. So we go to certificate management and we want to import that certificate. You can do that in the lab in a few minutes as well. So I will import first a key, okay, F5 demo, for example, and I will choose the file. It's on your Windows jump hosts under documents, and then exercise subfiles. The key will be this one, VLAB F5 demo con key. So I will import the key first, and then I will import the certificate with the same name. So in the GUI, it will be shown as one object. You can start from certificate and then import the key. So it doesn't matter. Did I click import? No. I already exists. So I have the key, F5 demo. Oh yeah, it's already imported. Really? RSA certificate and key. So whatever. You import key, then certificate, and then you will see something like this. Okay, I've chosen exactly the same name. That's why it didn't allow me to import that once again. So I have those files here, and then I go to profiles. Okay, so I have profiles, SSL, and I want to create the decryption from the client side, not server side, client side. So I go to client side, okay, and then I will create my client SSL profile to decrypt the traffic from the client side and use this imported SSL certificate and key F5 demo, and that my custom SSL client profile, right? Let's leave all of those options. As you can see, F5 can do a lot of different things according to those settings. What I have chosen, probably I've selected wrong things here. Error reading keep. Okay, so once again, quickly import once again something because I'm not sure what's wrong. Let's call it test. Yeah, that will be the key. Yeah, import. Then once again, click test and import the certificate for that file. That's the certificate. Yep. Yeah, pretty much the same. And now it should allow me to create this SSL client profile. Test. Test and key test. That should be fine. I didn't create those, yeah, at the crypt. Yeah, the problem is that the file probably can be somehow secured. So there's a possibility that there's some kind of passphrase needed for that. But normally you would go through this configuration. I will have to review our lab guide if there's any kind of passphrase. You can review that step by step. So it will allow you to do that. Yeah, there is a passphrase. Let's try to do this once again. Passphrase. Finished. So what are iRules? If we talk about, if we talk about iRules, those are scripts based on Tcl, which is tool command language. This is some kind of programming language that F5 decided to use as iRules within the TMOS interface, within the TMOS operating system. So this is nothing in addition to your big IP. This is something what is built into big IP from the beginning. So F5 decided to create their big IP many years ago with implementing iRules from scratch, right? So what you can do with this, of course, you can do a lot of different things with iRules. You can customize some features on Big IP itself. You can intercept traffic, you can inspect the traffic, you can modify the traffic, you can redirect the traffic depending on your needs, depending on the conditions that you create. And it doesn't matter if it has to happen on layer 4 or maybe layer 7. You can do actually everything here with those iRules. And everything is documented by F5 and everything is supported by F5. So it means that if something goes wrong and you bought Big IP and you have a support, you can open tickets for that, that something is not working. Maybe you have issues with some scripts. Everything is supported by F5. So this is really powerful and flexible way of programming your big IP to fit your needs. Those are iRules. So of course, F5 says that if it's possible to configure something on your big IP without using scripts, so customizing code and so on, you should use it. So if there are some built-in features, modules, or you can use local traffic policies, which we are going to cover in just a second as well. So in that case, you should use those 3 options. But from my experience, you can be sure that you will use iRules very, very often because they are so flexible and so easy to use, actually, because usually this code is very, very simple. And that if you start using iRules, you can do a lot of different things inside iRules, even instead of building features, honestly. Okay, so those are most commonly usages for your iRules. So some conditionally selecting our applications in our backend, right? So we conditionally selecting different pools. And this is something I'm going to demo in just a second. Conditionally load balance to specific server, maybe redirect from HTTP to HTTPS. Yesterday we finished with SSL, right? So usually we want to publish the application which is encrypted, right? But you have to redirect the traffic from unencrypted virtual servers. So we create both virtual servers on HTTP and HTTPS. And with simple default iRule, you can always do this redirection to HTTPS traffic. I will show you that iRule in just a second. Or many different ideas that you can have for using iRules. So when using iRules, this is event-based language. So it means that the specific iRule, specific code is triggered by specific event on your big IP when the traffic is passing through your big IP. So it means that, let's say that we have TCP commit connection, so we can use this kind of event, client accepted, okay? If it's a request at layer 7 with HTTP traffic, this will be this kind of event. So on different levels of or points of the traffic, which is traversing your big IP, you can execute specific code. So that's the goal. How do you create iRules? Of course, iRules can be created locally on big IP. This can be created externally. For example, there are some add-ons to Visual Studio Code, for example, but most of the times, simple iRules will be created like here. This is here on specific tab on your big IP. So we create the iRule, and there you will have some suggestions, context help. So everything is here. This is pretty nice. From this context help, for example, you can take some examples, read what you need, and maybe those examples will fit your needs exactly, or maybe after some customization you can do something. And some examples here, HTTP redirects, for example. So when you get specific HTTP request, you can do a redirect. So when your request, right? So this is the event HTTP request. When the host name ends with abc.com, for example, you can redirect the traffic somewhere. Or maybe something that we are going to do in just a second. When HTTP request comes in, and if the host name contains something, okay, this is the name of the FQDN that the user puts into the browser, then we are using this application. If there's something different, we are using different application. So in this case, for example, on one virtual server, something that we created yesterday, one virtual server being sent, the traffic being sent to one pool, default pool, what we can do about that, we can actually conditionally publish plenty of applications on one virtual server, and based on this host name, we can put that traffic depending on the application that you have. So you have one IP externally, but internally you can load balance the traffic or forward the traffic to different pools, meaning use different applications from one IP address that is accessible from client perspective, okay? And this is pretty much the same still, some kind of server, right? So we are redirecting the traffic based on URLs. Here, we are redirecting that based on FQDN and based on host header. Here, we are doing the same with the URLs, okay? And yeah, you apply that iRule to your virtual server and everything should be working as expected. You can do pretty much the same with, of course, maybe not pretty much the same, but some basic features from iRules can be achieved with local traffic policies. So if you hate scripting, if you're not a programmer at all, okay, so sometimes or very often, instead of using iRules, you can use local traffic policies. So you are using actually the GUI environment to modify that. And the same is here. If the host name starts with app1, forward the traffic to specific pool. If it's app2, forward the traffic somewhere else. So we can do the same, what we are doing in the iRule, you can do the same in those scripts, okay? So this is something we are going to do in few minutes from now, okay? So let's start that configuration. Let me try to go to my, where is it? Yeah, this one. Okay, what I created. So I have three applications. Let's say I have pool 1, pool 2, pool 3. Just like yesterday, I have one pool member in each of those pools, right? So 11 in pool 1, 12 in pool 2, 13 in pool 3. And what I have as well, I have configured my hosts file to have one IP address pointing, I will point three different applications, app1, app2, app3, to one IP address, so one virtual server. So what I'm going to do, first, I'm going to create the iRule, okay, which will redirect or forward the traffic to different pools based on host name. So the event, when, what, HTTP request, right? So I have HTTP request coming into my virtual server, and I have to create some kind of condition, okay? So I will have a condition if something happens. So for example, if HTTP host, okay, and I can try to do like something like this. So if I don't know the how can I use it, I can take it from here, okay? So at least I have something else, something more. So if HTTP URI contains maybe equals, for example, app1, right? App1, company.com, then I will forward the traffic to pool number pool 1, right? Else, I don't know. Let's try to reset the connection or reject, right? iRule 1. Whatever. Okay. So for now, I will try to add that iRule to my virtual server. That will be this one, HTTP virtual. I will get rid of my default pool, so I don't want to have it. Okay, none. I will delete this persistence profiles just for you to see that I'm not using anything here. I will use just my iRule to forward the traffic. So I go to my iRule here, finished. And right now I have only app1 and everything else should be reset, right? So when I go and I try to use my IP address for that, that should be reset, okay? But if I will try to use app1company.com, let's try to copy paste that. It's not working. Oh, sorry. Why it's using HTTPS? I don't want to use HTTPS. Okay. So it goes here. Of course, after refreshing it, it should be using only that's something I wanted to show you. HTTP virtual is the one. 10.1, 10.20. Which virtual server I'm modifying? Yeah. So not the one. Port 80. Get rid of this. That's why I was using HTTPS. Okay. Because I'm load balancing the traffic. The traffic should be passed to one pool member, the first one, right? Just a second. Oh yeah. What else? This is something from yesterday, of course. So company.com. That should be fine. HTTP. No. Yeah, that was the example. That should be host, not URI. My bad. Apologies for that. But after you refresh your iRule, then everything works fine, right? So actually, don't have to modify many different places and so on. Just refresh your app, and then that's it. So for new connections, already this works with this. So if I would like to do something else with this, I can do else if, for example, let's try to delete that one, that one, that one. Okay. This one as well. So this will be the else if, and the same for up to, for example. So if you need to publish second application on the same virtual server, so just backend, you can put up to company.com and redirect or forward that to pool 2, P2, for example. And maybe I would like to insert some kind of header. In this case, HTTP : header. Sorry. Header insert something exported for or whatever it is. I don't want to lose time for that. So just to show you that it will work right now. Also for app 2. So if I go to app 2, I should see everywhere node 2, right, with pool number 2. And the same can be, a lot of different things can be used with iRules. So this is very, very, yeah, nice option to customizing your configuration on BigIP. If you don't like iRules, you can do the same with local traffic policies. So I will create a one policy. Okay, so yeah, here. So just do that in 2 or 3 minutes. So I can create some rules. So app 1, let's call it like this. So in this case, when the traffic comes in with what? HTTP host. So host part of this is app1 company.com, right? Then do the same, exactly the same, so like with the iRule. So forward the traffic to the pool, which is called P1 in that case, right? Save it. Additional rule, you can do something else. I can have multiple conditions and multiple actions for every of this condition that they create. So app 3, let's say, in this case, for app 3, HTTP host will be, for example, host is or starts with, for example, it really depends, app 3, in this case, at request. And then let's do, I don't know, you can disable web application firewall. You can add some headers, delete some headers. In iRules, you can play with payload as well. Here, only with headers, but that's more than enough in most cases. So forward traffic, pool, and then let's put it to pool 3. Yeah, options, maybe I want to enable or disable. I want to disable SNAT completely, for example, for that option. Yeah, done, save. So when I publish my policy, because I have to create a draft, this is a temporary policy, I will publish that policy and then apply that published policy to my virtual server instead of the iRule that I have. So those conditions from this local traffic policy will take the traffic and do something about that, okay? So when I go to HTTP virtual, yes, that virtual server, then what I can do is I can delete my iRule completely. So I won't have anything here, right? Normally I will reset the traffic even for app 1, for example, because I don't have any pool. So for now, let's try to apply that policy that I created, and that's it. Reload, and now it should be fine. App 1, and something that I created, app 3. Take a look on the client IP address here. I'm doing this source node from yesterday, you remember? When I go to app 3, I conditionally disabled, in this case, this source IP translation. So in this case, I'm going to the same virtual server, but I'm not translating the IP, and I'm forwarding the traffic to different backend pool